Output of numpy.where condition is not an array, but a tuple of arrays. Why? I am experimenting with the numpy.where condition, x, y, function. From the numpy documentation, I learned that if you give just one array as input, it should return the indices where the array is non-zero, i.e. true. If only condition is given, return the tuple condition.non-zero, the indices where condition is true. But if try it, it returns me a tuple of two elements, where the first is the wanted list of indices, and the second is a null element. So the question is, why? What is the purpose of this behavior? In what situation this is useful? Indeed, to get the wanted list of indices I have to add the indexing, as in, np.where array greater than 40, which seems ugly. Addendum. I understand, from some answers, that it is actually a tuple of just one element. Still, I don't understand why to give the output in this way. To illustrate how this is not ideal, consider the following error, which motivated my question in the first place. So that you need to do some indexing to access the actual array of indices.
In Python, 1 means just one, can be freely added to group numbers and expressions for human readability, for example, 1 plus 3, 3v, 1 plus 3, 3. Thus to denote a one-element tuple it uses 1, and requires you to use it as well. Thus is a one-element tuple, that element being an array. If you applied where to a 2D array, the result would be a two-element tuple. The result of where is such that it can be plugged directly into an indexing slot, for example. Should return the same things as would, or with your example. equals 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 np.flat non-zero shows the correct way of returning just one array, regardless of the dimensions of the input array. Its doc says this is equivalent to a.ravel non-zero, 0. In fact, that is literally what the function does. By flattening, it removes the question of what to do with multiple dimensions. And then it takes the response out of the tuple, giving you a plain array. With flattening, it doesn't make a special case for 1D arrays. Equals 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 equals. At Divakar suggests np.where, which does np.transpose np.where greater than 4. Or if you don't like the column vector, you could transpose it again. Except now it is a 1xn array. We could just as well have wrapped where in array. Lots of ways of taking an array out the where tuple, 0, I, equals, transpose, array, etc.
Short answer, np.where, is designed to have consistent output regardless of the dimension of the array. A two-dimensional array has two indices, so the result of np.where is a length 2 tuple containing the relevant indices. This generalizes to a length 3 tuple for 3 dimensions, a length 4 tuple for 4 dimensions, or a length n tuple for n dimensions. By this rule, it is clear that in one dimension, the result should be a length 1 tuple.
Just use np.isArray function in your case.
Ja, ganz das Neue. Ja, das kann ich nicht